hope you are doing good. So today we will see a new DSA question. This is a question which is recently asked in one of the interview. So let's discuss it. So first we will discuss the question. We will understand the question with multiple examples, and then we will discuss the solution algorithm, and we will run the we will do the dry runs over the algorithm, and then we will run. I will implement that algorithm into the C++ code, and then I will run the multiple use cases there, and I'll show you. Meanwhile, if you have any question, then you can comment below the video. I will address those comments into the next upcoming videos. So let's understand the first question here. So the question is basically we have to find n numbers that are k almost prime. Now first we have to understand what is k almost prime. So it is given in the question, and if it is not given, then you can ask from the interviewer, and you can like get it clarified before like jumping on the solution. So it is saying a number is called a k almost prime number if it has exactly k prime factors, right? Counting multiplicity, here it is given like you can count the same prime number multiple times as a factor, right? So let's take an example and understand it. What is k almost prime number? So for example, right here, the input example is given, n is 5, right? We have to find 5 numbers which should be k almost prime numbers, right? And k is given 4. So I'll take here. So for example, k is 2 only, right? Means we have to find a number which should have 2 factors, and both of them should be prime numbers, right? So for example here 6, right? So 6, the factor of 6 is 2 and 3, right? 2 is prime number, 3 is prime number, correct? And we can say like right, and then we have here 9, right? 9 is 3 is prime, right? 3 is prime. So these are the k prime numbers, correct? And if we take like a k is for example 3, in this case the prime number, so the k almost prime numbers would be like for example 8, right? 8 would have 2 and 2, right? So 2 to 4, 4 to 8, right? And these are the prime numbers basically, right? And here it is clearly mentioned same number, same prime factor can be counted multiple times. That is what I am doing here. I hope you are okay with it. We have to find n numbers which should be k almost prime numbers, right? So now think about the solution algorithm, and yeah, I'll discuss my algorithm, whatever I'm thinking, and you can, if you are thinking different than me, then please comment below the video, so that we also get to know what you are thinking, right? So my approach would be here I would take one array, static array, where I will store all the like some prime numbers, right? So for example, I will say I will take a p array which will hold the prime numbers, so 2, 3, 5, 7, right? So it will it depends on the input n and k. So here I have took like till 23, right? Or you can say it depends on you, like how many numbers you want to include in your prime number array. And then what we will do, we will start from n, right? And num will be the number we will check from 2 to onwards, right? All the integers from 2 onwards, and then we will count the factor of the number. And if the factor of number, right, and here we have prime number, so what we will do, we will check if the particular number is completely divisible by that prime number, then only we will say let's divide it and then increment the count. Else we will not divide it. We will check here next line the f count, right? F count is equals to k, then only, and then we will say temp is 1. Temp, here temp, what is temp? Temp is like every time we are keeping that number into temp, and then we are performing the operations for checking the prime k almost prime factors, right, of the temp number, right? Not the num. Else what will happen if we use num? Then num will be modified, right? And that original value of num will be lost. So that is why what I am doing here, I am taking this num to the temp, and then I am performing this operation on temp. right? And if it is successful and f count is k and the temp is 1, means there is the number is completely divisible by all the k prime factors. Then we will go and we will add that input into the res array, right, result array, right? So I hope you are getting it. So let's try run this algorithm. So what we are doing generally, for example, we have n is 1, right, one number, and we have to find one number which is divisible by k is, for example, 2. Means the number should have two prime factors. So what we are doing here, basically we are starting from 2, number is starting from 2 onwards, and we will check all the numbers 2, 3, 4, 5, 6, 7 and up to n, right? Up to max integer, whatever the possible. And each time we have already prime numbers array. So we will divide that number into from the this prime numbers, and if it is divisible, then we divide that number, and we will keep doing that till it is not divisible, right? And then only we will say, then we will check for the next prime number. If the number is less than the prime number, then we will say, yeah, this is all done. And then we will check for the f count, factor count. If the factor count is equals to the k, whatever the we need, then and the number is 1, right, means it is completely divided. In that case, we will add that number into the result array. So that is what we are doing in this algorithms, right? So I will just comment below the video. I will provide you the link of this code, and there you can also try this code, right? So let me do some dry run. So here, for example, n is 1, so we need one number, and the k is 2. The number should have two prime factors only, right? So what I am doing here, we will start from 2, right, as I already said. So num would be 2 here, correct? And then here n is 1, right? So we will go inside this while loop, correct, this while loop. And then here I have f count and temp, right? Temp would be num is 2, so temp would be 2 only, correct? And here f count is 0, so f count is 0. And then we will go inside this for loop here. So for loop, what is it? Basically it is checking for it is p is this for loop is for all the prime numbers, right, whatever we have in the array, right? It depends on the input, or whatever the limit you want to support, correct? So first p would be the first number, that is 2, correct? And then we will check if temp modulo p equal to 0. So 2 modulo 2, that is 0, like it would give the remainder 0. So we will go inside this one, and then we will divide the temp by the p, right? So temp divided by p, that is 1. Now temp would be 1, and f count would be 1. I will increase the f count here, correct, from here. And then what we will do, we will go again into while loop and check. So temp is 1 modulo 2, that will be 1, so the condition will be false. So we will come out from this while loop here, and we will check here f count. So f count is here 1, you see f count is 1, and k is 2, or k is 2. So this is not the true condition, so we will not go inside this if block, and we will check here temp is less than p. Yes, temp is 1, and or p is 2, correct? So it means no need to check the for the prime numbers, right? It is not completely basically it is completely divisible, but not fulfilling the condition for of the k prime factors. So now what we will do, we will come out from this this block, right, here, this for loop block, and then we will increment this number 2. So now num would be here 3, right? Num would be 3. So now num would be 3, and then we will go again and check here f count is 0. Now again we will set f count is 0, and then we will set here num is the temp will be num now, so that would be 3, correct? And then we will go inside this for loop for the prime number. We will check all the prime factors, right? So 3 modulo 2, p is 2, correct? First number is 2 in the prime number array. And then we will check here temp is 3, 3 modulo 2, that would not 0, right? So it will come here and check the f count is 0, and k is 2, so it will not go inside it. And here p is 2, temp is 3, right? So it will not break the loop. This for loop will not be break, so it will go again, and p will be incremented. Next p number will come here. So now p would be 3 here, right? P would be 3, and here check 3 modulo 3, that is 0, correct? It will go inside it, and it will divide it. So temp would be 1 here, and then f count would be 1, right? and then again it will go into the while loop and check here 1 modulo 3, that would be 1, so it will not go inside it, and same applies here. F count is 1, K is 2, so right, it will not go inside it, and here temp is 1 and P is 3, correct, in this block, and here the loop will break. This prime number for loop will break, right, and it will come here and it will increment the number. So here number would be 4 now, and then what will happen? Now F count is 0, again reset to 0. So F count I will say 0, and then here temp would be 4, right. I'll copy the number into the temp and I'll perform the operation on the temp now. So P would be now first number again 2, and then I will say here this while loop, what it will do, it will check for the divisibility. So temp is 4, 2 is the prime number, so 4 modulo 2, that is 0, it will completely divisible. So we will go inside this loop and we will divide it. So now 4 divided by 2, that is 2. Here F count would be 1, here we are incrementing the F count, right, one factor, it is 2, and then it will go again and check 2 modulo 2, that is 0, correct. So now it would be 1, right, and F count would be 2, and then again 1 modulo 2, that is 1, so it will come out from the while loop, and then here we will see F count is 2, here see F count is 2 and K is 2, so this condition is true. Now we will check for the temp, the number is it completely divided or something is remaining in that number. So here temp is 1, right, temp is 1 here, so 1 equals to 1, that is 1, right, true, this condition. So now we will add this number into the resultant array, right. So this number will be added, basically number what, 4, correct, this is added into the result, right, and here we will decrement the n, right, n was 1, right, so now n will be 0, and then we will come out here, and here temp is 1 and P is 2, sorry, right, so it will break the loop, and here come here, right, n will be incremented, number will be incremented, but it doesn't matter, right, number would be 5, but here it will come here in the top of the while loop and see n is 0 now, because n got decremented here, correct, 0, so it will come out, and then we will result the whatever the result, basically whatever the value we have in the resultant array, right, and that is 4 only. So this is the simple example I took for the one number and for the two factors, right. So likewise it will be applicable for the all the numbers, right. I hope you understood this algorithm. It is very simple. You just have to take care of the prime numbers, and you have to start from the 2, and then you have to keep dividing if it is divisible. Prime factors can be multiple. The same prime factors will be counted multiple times, correct. So now now what will I do? I will show you the code, and then we will run the multiple use cases there. So here this is the code, you can see, and here simply I took the prime number array, then this is the resultant array where I will store the result, and I am starting from the 2 number, right, and here n, for all the n, whatever the requested numbers we have to find, that is n, right, and every time whenever we find the result, right, then we will decrement that n by 1, correct, and here for all the prime numbers we divide that number. I am taking that number into the temp and I am performing all the operations on the temp, correct. I hope you got it. And then here we are checking the condition, whatever the condition we want, right, for the k prime factors, and if the condition is fulfilling, then we will add that into the resultant array, and then we will decrement the n, correct. And then once and here I have added one more condition here to say like this number is not supported, because we have taken here a limited prime numbers, basically, right. If our condition like n and k, and where the number is going out of the range, right, and that like that condition is not fulfilling using these prime numbers, then we will say, yeah, this number is not supported, correct. And then here this is the main code, so let's run it. If you want this code, then please comment below the video. I'll provide the link so that you can also get it. So I have already built it, so I am running it. So let's enter the use case. So we will see, we will try the 3 use case, and the first number would be, for example, we want only one number, right, and then or you can say 5 number, and the factors should be, for example, 2 only, right, 2 factors. Each number should have 2 factors, and both of them should be prime numbers. So let's see. So 4 is that number, k almost prime number. How? Because 2 and 2 is 4, 3 and 2 is 4, right, 3 and 3 only two factors, and both of them are prime numbers, right? 3 and 3, 9. See, 5 and 2, 7 and 2, right? Correct. Now let's see, try 5 number and then 3 factors. See, 8, 12, 18 and 20, 27, right? So these are the numbers which are fulfilling the k prime, basically almost k prime factors condition, right? Here 2, 2, 2, right? It would be 2, 2, 3, 12, right? It would be something, and then 20 and 27, like this, right? And you can say, like, if I say 8 and then you can say 2, then see, these are the numbers. Right. So I hope you understood this one. This is the very simple algorithms. You have to basically stick with the basics, where we have to divide by the prime numbers only, and we have to check if the number is completely divided or not. That is what we have to do. Thank you for watching the video. I hope you understood it. That's all for today. Yeah, see you next time. Till then, keep learning and keep exploring.